Hello, guys, and this is lecture one of a playlist series. We'll be covering the control systems course, and today we'll be going over a couple of things. So let's note it down. So the learning objectives for today. So the learning objective for today are as follows. So we're going to define the definition of a control system. Then we're going to be talking about the system response. What is it? Why they're important? Then we can configure the system response in a couple of different ways. So mainly the open loop system, the closed loop, and then we'll be looking at block diagram examples to finish off the lecture. Okay, so to start off this lecture, we need to understand what a control system is, right? We have to define a couple of things to be able to understand what a control system is. So the definition of a control system, there are many definitions online, but one I found interesting was it's a network of interconnected components designed and configured to manage a device or process so it behaves in a specific and predetermined way, which is also, we can call it the output. Okay, so from this we have now seen there are a couple of things here we need to further define. Okay, mainly there are things such as what is a process, right? What is a process? Also things such as what is a system. Okay, so we can also define these things over here. So I'm going to perhaps change the color. Let's define these things here. So we have a system. Now system can be defined by it's an interconnection of elements and devices for a desired purpose. Okay, so let's see if I move this across. There we go. Move this here. All right. Another thing we can talk about is the process. So before I go into details about the control system, let's define the words that are being used. So this is a system, a network of interconnected components. That's basically a system. So if you want to see, so what we're talking about here is actually that all of this is actually the system. Okay, so let's go here and let's also define what a process is. A process is the device or plant or a system that is under control. Okay, that is the process. And this can be described in many ways, so this is not just the only definition. There are lots more definitions. Another thing that we can use or will use a lot in this course is the word actuator, right? So to define it, again, I'm going to define, let's use another color. So actuator, and what is it? So an actuator is a device that is employed by the control system, so by the control system to alter or adjust the environment. Okay, so at this point we can also talk about a sensor. It's a measurement device. So I'm sure that you know what a sensor is, but even if you don't, we can also define it here. So let's say a sensor is a measurement device. Okay, so this could be touch, this could be voltage, this could be any sensor that you can think of, that anything that measures things is what we call a sensor. Okay, so we can describe our system. So this is our system that is designed to configure and manage a device or process. So there's some process going on before it behaves in a specific way, which is called the output. So we can actually make a diagram to show this. So let's call this our control system. Let's go over here and say this is our control system. All right, now from this we have an input. So we have an input and we have an output. We have an output. Okay, so we can say many things. We can describe this input in many ways. We can call it many different names. So we can call it the input or the stimulus. Conversely, we can also call the output not just the output, but we can also call it the, so let me see if I can get it here. There we go. Okay, we can call it the output or the response of the system. In control theory words or in control theory terminology, this is known as the desired response. So response. So let me move it out of the way. There we go. And the other one is known as, or the output rather, is known as the actual response. Okay, so now we have described a control system for you. Let's now talk about the system response and why it's important for us to understand what's going on here. So let's take an example down below. So let's go down here. Now imagine that we are going in an elevator. So these are the elevator doors. These are the elevator doors. Oh, nope, not that. Let's delete that. Number 2, yes. So imagine these are the elevator doors. And we have a person approaching the door. And before he approaches the door, he has these icons that he can press to go up or to go down, right? So to go up or to go down. So let me just describe it. So he's either going to go up or he's going to go down, right? So let's make it a bit more clear. You get the gist, right? Okay. Now from this, so let's go here. We have a person that is entering this elevator, right? So he's in ground 0 at the moment, okay? He's at ground 0. He's going to go to the 7th floor, all right? So he's going to go to the 7th floor. Now we can describe this. So to speak. Let me do it. Let me move a bit to the left. We can describe this phenomenon in a graph. Okay, so I'm going to show this graph over here. So we can model its journey from 0 to 7th floor. Okay, so on the x-axis, we are looking at the time, right? We're looking at the time. On the y-axis, we are looking at the elevation location, or so to speak, so which floor he's in, right? Which floor this person is in. So which floor he's in. So once, let's give this person a name. Let's call this guy Sam. When Sam clicks this icon over here, so maybe let's make it a bit bolder. He clicks this up icon. He wants to go from directly 0. So he wants to go from 0 to 7, right? So he gets to have this input over here. Let's call this the input. So this input command of 7th floor direct, right? I want to go to the 7th floor directly, okay? But is that what actually happens? No, it's not. What happens is he goes from 0 to 1, so 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7, right? So maybe let's make it a bit more X. So 1, 2, 3, 4, 5, 6, 7. He takes 7 steps, or goes over from 0 to 7. It goes gradually, right? It's gradual in nature, right? So for this, there is some sort of gradual change. So he starts off from 0. So I'm going to change the color, and I'm going to represent this much better. So we start from 0, elevator is increasing in speed, and then it levels off at this over here. So maybe let's make it a bit more concise. It goes up and then plateaus at this point here. Or better yet, let me go the other way around. Okay, that's even worse. Sorry. Plateaus. Okay. All right. Just assume that over here it's straight. Okay. So my bad over there. All right. So why is this important, and why are we considering all this information? All right. Now, what's happening here is the red. Let's call this red as well. So let's put the elevator in red. Put the elevator in red. Okay. Why we're doing this? This is the red line that we have drawn is the elevator response. So this is the elevator response. Now you can see it's gradual in nature, and what happens there is there are two processes or two different graphs that are plotted here. So for example, I can say that it's increasing from this point to this point here, and then it is steady, right? It's steady. Now it's in the name, so that means that at this point over here, from here to here, we call this the steady state response. So steady state response. Okay. So what do you think we call this response over here? So let me go back. What do you think we call? Let's change the color to here. What do you think we call this response? This response here. So this response here, from here to here, we call this the transient response in control theory terminology. So we're going to call this the transient response. Okay. Now, in this transient response, there are multiple factors that can change the output different from the input. So you can see that the input over here, so if I have the laser pointer, it changes gradually, right? Changes gradually. So the input's given at 7, right? But the output or the elevator response is gradual. Now, you can see that at the end, there is some sort of discrepancy. Now, we call this discrepancy the steady state error. Now, this error is normally not wanted by the system, right? We don't want this in our system. We don't want an error in any of our responses at the end. So if I'm going from floors 0 to 7, I want to arrive at 7, right? I don't want to arrive midway between 6.5 and 7. So this is called the steady state error. So for example, let me see if I can show this to you in a different color, perhaps black. So this error here, from here to here, this is the steady state. Okay, let me move back a bit. Let me go here. Let me write here. Okay, steady state error. Okay. So now we've understood that there are a couple of things that we are looking at, right? There's steady state error, and there are. So we can say that there's a lot of steady. We're trying to minimize the steady state error when we are configuring these systems. So now this system can be configured in two different ways: an open loop control system or a closed loop control system. Now, what's important is that we're going to go over one at a time. So we're going to just go down here, and we're going to define a control system. So let's expand on what we had earlier. So initially we had, if you remember, if we just scroll back up again, we had this control system. So I'm going to just see if I can just copy it. And then we're going to go down, and we're going to expand on this idea. We're going to expand on this idea. So let's drop this a bit back. And what we're going to do is we're going to split the control system into 3 subparts, or mainly 2, but then they can be written as 3. So I'm going to get rid of this control system, and I'm going to say that there are a couple more. So for example, let's Control Z, Control V here, and another one here. So here, let's see if I can make this over here. This is what makes the control system where the process happens, right? So obviously these are connected, so they're connected, and then so they're connected as well. So let me see if I can show you guys. This is just cosmetics, to be honest, for now. But if I can hold it, okay, I cannot. Yeah, hold on. There we go. Okay, and here we go. All right. Okay. So what are these systems, right? So this control process system can be broken down further into something that controls the input. That is what we call the controller, right? And that controller, that's odd. What's this? Let's do this. So the controller, as we were saying, controller that controls the amount of input that we're giving to the system, right? And then we're going to talk about, if you remember, we talked about this thing called earlier, we said an actuator. So it's a device that is employed by the control system to alter or adjust the environment. So we're going to use this, so the input that we give is going to directly affect the actuator, which will do something for the process, and then we're going to get a response. So, like I've described earlier, all we have to do right here is this is the actuator, right? Now this actuator then goes to the process, and then we get our actual response. An easy way of this is, for example, a water heater or a toaster, for example, that what happens in a toaster is that you have the toaster, and let me draw it for you so it's an easier way to understand. So if we have a toaster, if we have the toaster and we drop in a loaf of bread, right? We drop in a loaf of, or like a slice of bread. It's not going to know when to take it out. We're just going to have that bar over here, that thing over here, and it's just going to spit out. It's just going to spit out the. So if you can imagine, this is. We don't know whether it's burnt or not. It's just going to go in. All right. Now, the good thing about this is that it's very easy to implement. They're cheap, right? But the bad thing about an open system is that it's not very reliable, and there are many errors that can be in the system. So to mitigate this, we come up with something called a closed loop system. Now, why is this important? So we're going to have the same diagram, right? The same diagram, but we're going to do something different. So let's see if we can do something different. So let's see if I can, or perhaps this is the last selection. So here, here, here. Okay. And let's go down over here. So now, just going to paste it here. Now, instead of this, I'm going to get rid of this. Instead of this now, maybe let's make this a bit more easier. There we go. Let's move this here. So to give some space. Okay. Now, a closed loop system, we have something that we can use to change the error, right? Or to change the system response to give us our desired response. Right? This is our desired response. We want this. We want this desired response. So another way of calling this desired response is to call it something else. We can call this the reference input, or the reference point, or the reference input. Okay. Now from this, so we're going to have this reference input. It's always here. And we're going to keep this going, and this is just the output. Okay. So this is just the output. All right. Okay. So we have something called a feedback mechanism, right? Which detects the changes in the system and tells the system or the controller that there needs to be something done. So what we can do here is we can have another box here, which we can call the feedback. Now this feedback is usually done by a sensor, right? Okay. So how did this fit into the comparison? So let's go here, and it's here. Okay. Then from there, we have, it goes from the feedback and then goes up to the reference input. Now, you might think what are we affecting, right? There is something that we are affecting, right? And what we are affecting is we're affecting the error. We're affecting the error. And we represent this by this circle here. So we say that this circle is called the error detection. So let's call this the error detection. Okay. So let's move this here. Now, what do we want to know from this error detection? We want to minimize it, right? That's the whole point of the feedback system. And because we want to minimize it, we say that this point here, the arrow that's pointing here, is pointing to a negative. So we're trying to decrease the error. So we're going to say this is the negative part of the loop. So we call this here, let's increase this. This is a negative. And whatever we put inside the reference input or before this, this is going to increase the error. So we either increase or decrease the error, right? That's the only possible situation here. So we can say over here that we have a plus icon on this side. So maybe if I move this here, and we move this here. And these arrows or the signs are very important because the feedback is trying to decrease the error. And alternatively, what we input will have greater error than the feedback that we're getting, right? Okay. So now let's go and try some examples of diagrams, all right? Block diagrams. So to begin with, let's give an example that we have done before. It's a car. So we can say a car that is veering off to the left. So, or rather not, let's give another example that will be even better. Let's give an example of all right, okay, let me type this out. So we're going to give an example of a human operator as the controller in one of the blocks. So this is the question. Draw the closed loop control system for controlling fluid flow, and I'll describe a picture to you as well. Identify all the elements with their proper labels. So for example, you need to mention the sensors that you're using, the controllers that you're using, and the actuators, and so forth. Right? So this is the question. Now let me show you what we are given, so to speak, in the question. And it is a so let's move down here. Let's draw the actual what we're given so it's easier to understand. So let's see. Okay, this is okay. So we have a tank. So we have a tank. The tank is here, and it's connected to a valve. So it's connected to a valve, and that valve is operated by a human. Okay, so all right, and so forth. So and so forth. Okay, now this is the valve, obviously. So we have an output of the fluid. So the fluid is coming outwards. And then what's happening is that we have the person. So we have a person. So let's see if I can draw the person well. Let's use stickman diagram, or much easier. So we have the person. We have the person who's controlling this. And there is a hole over here that they can use. So this is the human operator. So this is the human operator. And there is a meter, so to speak, that he can see. Okay, so this is the meter. and he can see what's going on here and so forth. There's a meter, and there's obviously, let's say there is some water inside. So let's just say there's some water. Let's just say there's some water inside the tank. Now your task is to identify all the elements with the proper labels for the block diagram and draw the block diagram for me. Right? That's the exercise. So you can pause the video right here, and you can try it, and then we'll come back to it. Okay? So now, assuming that you have taken your time and you have tried to draw the block diagram, let's go ahead and draw the same system that we can for this. All right. So what we do have, so in the beginning we have a desired. So we're gonna call this our desired fluid flow, right? Desired fluid flow, right? It's going to have the error, so this will be plus. Then we're going to have some feedback. So our controller is going to be the human, right? So our eyes, this is our control system. Then the actuator will be the valve, right? The actuator will be the valve. So our actuator is the valve. Okay, now the process is looking at the tank level, right? This is the process. So if we look here, and obviously, just so we're clear, there is obviously a before that was not shown. There is obviously an influx of liquid, right? That's going inside. This is the output, and this is the input. Okay, so I think perhaps would be better if I define it earlier, but that is my bad. Okay, so we have the valve. Now, what's the process? It's the tank level. So the tank level, and then this is going to give us the actual fluid flow. So this is going to give us the actual fluid flow. Okay, now how do we check this tank level? We use this sensor here, that is the meter, right? The meter that's provided to us. So we're just going to have another block diagram here for our feedback, and we're going to call this the meter. Whatever meter it's given, that's the meter that I've described to you, and we're going to add arrows, and then that's what we're going to have, the minus icon here. You don't have to write that there's an error, but this is what I would do. All right, best of luck, and I'll see you guys in the next lecture when we'll be discussing different sets of equations, and then we'll be trying to see how we can transform them into something that is mathematically a bit more rigorous. All right, take care.